Hi, I'm Angela.
And I'm Tina, and we're your hosts today on Mythbusters Genetics Edition. We're going to tackle the common misconception. If parents who are carriers for a disease have a child affected by the disease, the next 3 children are risk-free.
Let's take a look at this hypothetical scenario about parents Eli and Maria. Eli and Maria are both carriers for sickle cell anemia. Their first child, Alexandria, was diagnosed with sickle cell anemia. Since their first child has the disorder, Eli and Maria believe that their next children will be risk-free. What do we find wrong with the scenario? To help explain this misconception here today, we have a special guest host, genetic counselor Neha. Thank you for being here. Now, tell us what's wrong with the scenario.
We know that sickle cell anemia is a Mendelian inheritance disorder, and that if both parents are carriers, it can be passed on to their children. But what does this mean?
Well, first off, an autosomal recessive disorder means that 2 copies of the gene must be present in order for the disease or trait to develop. But let's not get ahead of ourselves. Let me show you.
So what does the lowercase a and capital A stand for?
Well, the letters help with our visualization of the disease. If the parent has 2 uppercase A's, they are dominant for the trait, and they are not carriers of the disease at all. If they have a capital A and a lowercase a, then they are still dominant, but they are a carrier for the recessive allele. If they carry 2 lowercase a's, then they are homozygous recessive, and the disease will be present, like in the case with Alexandria.
So Eli and Maria, they both carry a capital A and a lowercase a, and Alexandria carries 2 lowercase a's.
Exactly.
So then how did their first child, Alexandria, get sickle cell if both parents are dominant?
Well, it has a lot to do with probability, and a Punnett square can be used to show us. A Punnett square is used to assess the likelihood of offspring to inherit certain traits from their parents, and it kind of looks like this table right here. Taking the carrier parents' alleles, we see the probability of the potential outcomes of their children.
So does that mean that there is a 75% chance that their offspring will be dominant and not get sickle cell anemia? And that there is 25% chance their offspring will be recessive and have the disease?
You got it.
So if Alexandria is homozygous recessive, then why would the next 3 children not be risk-free?
As we know, both Maria and Eli are carriers. Their second child will also have the exact same chances that Alexandria had. This probability is the same for each and every child and does not change. Unfortunately, even though Alexandria has the disease, it does not lower the chances of any future siblings or any future children of having it.
So every birth is an independent event.
That clears up so much. So just because one child is homozygous recessive for a disease does not mean that the rest of the children are risk-free.
You got it.
Thank you so much for being here today.
It was my pleasure.